हेलो।
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 Yes, sir.
Am I audible?
Yes, sir.
Screen is visible to everybody? Hello. My screen is visible?
No, sir.
Now please check.
Yes, sir. Now visible.
Okay. Please draw this diagram. So in the previous lecture, we have finished with the potentiometer and potentiometer as an error detector. Okay. So in this lecture, we are going to discuss about the synchro. Okay. So first part is synchro as an transducer, and then in the second part, synchro as an error detector. Okay. So what do we mean by synchro? Okay. So synchro is nothing but basically it is a electromechanical transducer which convert a mechanical angular position of shaft into a electrical signal. Okay. So that's why it is called as a transducer. Okay. So therefore, again, synchro as an error detector. So we have seen how potentiometer can be act as a error detector. So for that purpose, we require two similar pots. So similarly here, synchro as an error detector, we require two synchros. So that's why synchro as an error detector is generally called as the synchro pair. And that pair of synchro, it consisting of two units. First unit is called as synchro transmitter and second is called as the synchro receiver, or sometimes that synchro receiver is also called as synchro control transformer. So this is a figure for synchro transmitter. So first of all, we discuss about the operation of synchro transmitter. How again synchro as a transducer. Okay. So in synchro pair, the first component is called as the synchro transmitter, and this is a simple construction detail of synchro transmitter. So the construction, if you carefully observe this, the construction of synchro transmitter is similar to the construction of three-phase alternator. Okay, it consisting of stator and the rotor winding. Okay, and the basic synchro unit is called as the synchro transmitter, and its construction is similar to three-phase alternator, but operationally it operates on the principle of transformer. Okay, so how it operates on transformer action, that we will see in the next part. Okay, so this is the basic information about synchro, and it can be act as a synchro transducer. Then how is the stator construction? What about the construction of synchro transmitter? So it consisting of two parts, rotor and the stator. Okay, so first we discuss about stator construction. So if you carefully observe that this is the stator, okay, and this stator has the slot at the inner periphery. These are the slots having at inner periphery, and in that inner periphery we have accommodated the three-phase stator winding. Okay, so therefore the stator of synchro transmitter is a stationary part and which has the slots at inner periphery and which can accommodate a three-phase concentric type stator winding, and which is generally star connected. The stator winding of synchro transmitter is generally star connected. and the shape could be it is cylindrical type. So this is all about the stator construction of your synchro transmitter. Then what about the rotor construction? How is the rotor construction? If you carefully observe that the rotor of synchro transmitter is just like a dumbbell. So that's why the rotor of synchro transmitter is dumbbell in shape, and it carries a rotor winding, and this rotor winding is supplied with a AC supply, single phase AC supply, and this AC supply is provided to the rotor with the help of this slip ring. Okay, so this is all about the rotor construction. Okay, so this is all about the construction of synchro transmitter. Then how it operate? Okay, so you will see this rotor is supplied with a single phase AC supply. Okay, and stator carries a three-phase stator winding. Okay, so that we will see by using this figure number 1. Okay, so this is a constructional detail diagram of synchro transmitter. Okay, so I request all of you, please draw this diagram. Then we go for the operating principle of this synchro transmitter. Then you can also draw a second figure. Yes, diagram over. Put the diagram. Yes, all of you finish the diagram. Okay. So this is the second figure. Again, this second figure represents a schematic of synchro transmitter. Okay. So we have simply simplified this first diagram. Okay. So we have seen the constructional detail of synchro transmitter. Its construction is similar to three-phase alternator. Stator carries a three-phase winding and rotor carries a one winding. Okay. So, and the stator winding is uniformly distributed along its periphery. Okay, so there, and the stator winding is connected in star connection. So therefore, here we have shown three winding S1, S2, and S3, which are displaced by 120 degree each apart. Okay, and we have shown here the reference axis, that is the axis of rotor winding, is called as the reference axis. Okay, because in order to show the electrical zero position of this synchro transmitter, for that purpose we have to consider the reference. So therefore we always take the rotor winding axis as a reference winding in the synchro transmitter. Okay, so this is the axis of your rotor winding. Then how to show the position of this rotor with respect to all these three stator winding. Okay, so therefore initially we have assumed that the initial position of rotor with respect to stator winding is denoted by theta, where this theta is the angle between rotor axis and the stator winding axis, S2. Okay, so if you want to determine what is the angle between rotor axis and stator winding S2, so it is denoted by theta. Then similarly we have represented what is the rotor angle between rotor winding axis and the stator S1 winding axis. So you see this, the angle between S2 and S1 is 120 degree plus this theta. So therefore angle between rotor axis and S1 winding is theta plus 120 degree. Similarly, the angle between rotor axis and the S3 winding axis is this theta plus this 120 plus 120. Therefore here we have shown theta plus 240 degree. Okay, so with respect to this second diagram, we can analyze the operation of this synchro transmitter. Okay, so on which principle your synchro transmitter basically works. Basically, your synchro transmitter works on the Faraday's law of electromagnetic induction, because basically it operates on transformer principle. Okay, so we are going to derive the expression for voltages induced in this S1, S2 and S3 winding, and on for which factor these voltages are proportional. Okay, so let's say consider a AC voltage applied to the rotor of synchro transmitter is given by, let's say it is noted by VR is equal to, or you can take the notation capital VR is equal to small VR sine of omega t, to be equation number 1 for this. So here we have applied a single phase AC supply to the input to the rotor winding. Then what will happen when sinusoidal voltage is applied to the rotor winding of synchro transmitter? As rotor construction is dumbbell type, it is just like a salient pole type rotor. Okay, so and this is the rotor, and when this rotor winding is supplied with a single phase AC supply, the current starts flowing through this winding. Okay, and as the current flows through winding, we know the property of any conductor. When the current voltage is applied to any coil, the current starts flowing, and as the current flows, it may develop the flux. So therefore, flux developed by this rotor winding is like this. So this one is, let's say, this formation of your north pole, this will be south pole. So these are the direction of the fluxes, and this flux is uniformly distributed along the stator periphery. Okay, so when we apply single phase AC supply to the rotor winding, it may develop the flux, rotor flux or rotor field, and that rotor field is uniformly distributed along this stator periphery like this. Okay, so like this way, the flux developed by the rotor winding is swept over the stator winding. Okay, so as soon as the flux linking with the stator conductor, what will happen? What will happen? Your flux is uniformly distributed in the air gap between stator and rotor. Okay, so and that flux is cut by the stator winding conductor. So according to Faraday's law, and EMFs are induced in the three-phase stator winding. Okay, but the magnitude of this induced EMF is proportional to what? इसको proportional रहेगी. Therefore, you see this, the voltages induced in this stator winding is proportional to the cosine of angle between this rotor and the stator winding axis. Okay, in this diagram, this is the axis of your winding. Okay, so if your rotor is fixed to this position, so these are the direction of the fluxes. Okay, so this may happen that if this rotor axis is coincide with S2 winding, then the maximum flux may link with the S2 winding, and minimum fluxes may link with the S1 and S3 winding. Okay, so that is why we say that the voltages induced in this stator winding is proportional to the cosine of angle between the rotor axis and the stator winding axis. Okay, and the voltage induced in the stator winding, we say that it is directly proportional to cosine of angle between the stator winding axis and the rotor winding axis. And what is the angle between stator winding axis and rotor winding axis? That is we have defined by theta. So therefore, voltages induced is directly proportional to cosine of angle between the rotor axis and the stator winding axis. Then in general, so what is the expression for voltage induced E? So this proportionality constant will be given by any constant K. okay, into the input applied voltage is VR sine of omega t into cos of theta. So this is the in general expression for voltage induced in a three stator winding. Okay, so now voltage induced in all three stator winding S1, S2, S3, it depends on the rotor position theta. Okay, then what is this VR sin omega t? That is nothing but your RMS voltage. So sometimes we may define it by K times VR into cos of theta, where, or you may use the notation ER also, where this ER is the RMS value of your AC supply. So KVR cos of theta. So this is the general expression for voltage induced in your stator winding. Then we can develop the expression for RMS voltages or with respect to neutral single phase supply or voltages with respect to neutral in the all the three stator winding. So how is the operation of this synchro transmitter? The operation is very simple. When we apply single phase AC input to the rotor winding, the current starts flowing to rotor winding. Okay, so it may develop the rotor magnetic field, and that rotor magnetic field is uniformly distributed among the stator periphery. Okay, and that rotor flux is cut by the stationary stator coil, three stator coil S1, S2, S3, and according to Faraday's law of electromagnetic induction, and EMFs are induced in the S1, S2, and S3 winding based on the transformer principle. So therefore, here we are say that your rotor winding is just like a primary of your transformer, and three stator winding S1, S2, S3 is just like three secondaries of the transformer. Okay, so in this way we can correlate this. Okay, then next we can define what are the voltages induced in the S1 winding, S2 winding, and S3 winding with respect to the neutral. Okay, so let the voltage Vs1n, Vs2n, and Vs3n are the voltages induced in S1 S2 and S3 winding with S1 S2 S3 winding with respect to neutral. Okay, so therefore N stands for the neutral. Then for the rotor position shown in figure 2, because we have seen that the voltage induced in all the three stator winding is directly proportional to cosine of angle between the rotor winding axis and the stator winding axis. So this is the axis of your S2 winding. This yellow line indicates the axis of your S2 winding, and this is the axis of your rotor winding. Similarly, this will be the axis of your S1 winding. This is the axis of your S3 winding. So the voltage induced is directly proportional to cosine of angle between the rotor axis and the stator winding axis. So therefore, as the rotor position changes, the voltages induced in the S1, S2, S3 windings are also changing. Okay, so therefore, we just write down the expression for Vs1n. So please tell me the expression for Vs1n. With respect to this reference position that we have assumed in the figure 2. Yes, anybody? So it will be given by voltage induced. Please remember, E is directly proportional to cosine of angle between the rotor axis and the stator winding axis. And for the reference, for this reference position, the angle rotor angle between S2 winding and reference winding is theta. Similarly, what is the angle between reference axis, rotor winding axis and S1 winding axis? That is theta plus 120 degrees. So therefore, S1. So here is your S1 winding and this is your reference position of rotor axis. So therefore, what is the angle between S1 winding and the rotor winding axis? Kitna angle hai ye? This 120, because all three windings are displaced by 120 degree each apart. So this is 120 and this theta. So that's why this could be total theta plus 120 degree. Okay, so please make this change. So this is theta. Okay, so therefore Vs1n is given by K times Vr sin omega t into cos of theta plus 120 degree. So why cos of theta plus 120 degree? So this 120 degree and this theta. Okay, so this Vr sin omega t, this is nothing but the RMS voltage. आप इसको ER से भी बता सकते हो. Okay, so give equation number 2 for this. And why this E is directly proportional to cos of theta? Please understood this. Voltages inducing S1, S2, S3 winding is directly proportional to the cosine of angle between rotor axis and stator axis. Why is it so? Because you see this, when we apply sinusoidal input to the rotor winding, it may develop the sinusoidal flux and which are sinusoidally distributed along the stator periphery. Okay, so that is why, and that when sinusoidal flux is cut by this stationary conductor, then the voltage inducing this stationary conductor is directly proportional to the cosine of angle between this rotor axis and the stator winding axis. So that's why E is proportional to cos of theta. Okay. So I hope it will be clear to you. So Vs1n is given by K times Vr sin omega t into cos of theta. So this Vr sin omega t, that is nothing but your RMS voltage also. You also represent it by K times Er cos of theta plus omega theta plus 120 degree, where K is the proportionality constant and Er is the RMS value of voltage which is applied to the input of your rotor. So this is the expression for Vs1n. Similarly, tell me the expression for Vs2n, voltage induced in the S2 winding with respect to neutral. Please tell me the expression from this figure to this proportionality constant is denoted by K. Okay. Then input RMS voltage applied input to the rotor is Vr sin omega t. Then what is the angle between rotor axis and the S2 winding axis?
Theta plus 240.
Kitna आएगा? What is the angle between? This is your rotor winding axis and this is your stator winding axis. So what is the initial angle? जो हमने rotor position figure में show किया है. What is the angle? Theta. Okay, so therefore K Vr sin omega t into cos of theta. So the equation number 3 for this. Is it clear to everybody? Okay. Tell me the expression for Vs3n. Vs3n. Now check the angle between your rotor axis and the S3 winding axis. What is the angle? from this up to this in the clockwise direction. So this is theta plus this is 240. So therefore theta plus 240 degrees. So therefore, what is the expression for VS3N? It is K times VR sine of omega t into cos of theta plus 240 degree. So give equation number 4 for this. Okay, so these are the, here we have measured the angle in clockwise direction. You can also measure the angle in anti-clockwise direction also. If you measure the angle in anti-clockwise direction with respect to this, so it could be 120 minus theta. Okay, so cos of 120 minus theta आ जाएगा instead of theta plus 240. So meaning will be remain same. Okay, so these are the expressions for voltages induced in the S1, S2, S3 winding with respect to neutral. Okay. Then next one, determine the terminal voltage of synchro transmitter S1, S2, S3, S3, S1, S3 and S2, S3. Determine the line voltages. So these are the phase voltages. Now determine the line voltages. Okay, so which is generally also called as the terminal voltages. So terminal voltages of synchro transmitter or terminal voltages of the stator is given by, so first terminal voltage we can measure between S1 and S3. Okay, so I may call it as V S1 S3, which is equal to, so how will you determine line voltages from the phase voltages? V S1 S3 कैसे रिप्रेजेंट करोगे? How will you get line voltage from the phase voltages? So let's say this is your VL. It is the phase difference of line voltage is nothing but the phase difference of two phase voltages. So therefore S1 S3 will be given by simply V S1 of N minus V S2 of N. Okay, so take the difference of equation 2 and equation 3, equation 4. Okay, so find V S1 S3. Please do it and tell me the value of V S1 S3. So V S1 N will be given by this K times VR sin omega t into cos of omega t. Again, this term is common, K VR sin omega t, K VR sin omega t. So I just take common K times VR sin of omega t in bracket में बचेगा आपका cos of theta plus 120 minus cos of theta minus 240 degree. Now simplify this expression and determine the V S1 S3. Please simplify this. You just apply the cos A plus B formula. Here is plus cos theta plus 240 degree. So simplify this V S1 S3. What you are getting, V S1 S3 equal to क्या आएगा? K times VR sin of omega t in bracket. What is cos A plus B? What is the formula of cos A plus B? Cos A cos B. Okay.
Minus sinus sin B.
Minus sinus sin B. So cos A is here what? A is theta and B is our 120 degree. So you just apply here cos theta, cos 120, cos A, cos B minus sin A, sin B. So minus of sin theta, sin of 120, correct? Then minus again here cos theta plus cos A plus B. So bracket cos A is cos theta, then into cos of 240 minus sin theta, sin of 240. Whole bracket completed. So put down the values. So here we are getting V S1 S3 equal to A times VR sin of omega t in bracket. Here is cos theta. What is the value of cos of 120?
minus 1/2.
Minus 1/2. So it is minus 0.5 minus sin theta, sin 120 value root 3 by 2.
3/2. Yes, sir.
Root 3 by 2. So our this term is over. Then second term we are taking minus of in bracket cos theta. What is the value of cos 240?
minus 1/2.
Minus 1/2. So that means again it is minus 0.5 minus sin theta into sin 240. Again sin 240 could be, what is sin
minus root
240?
3/2.
Minus root 3 by 2. So again minus of root 3 by 2. So this bracket, this is whole bracket. So now simplify this. So if you multiply this minus sign with this, okay, so because this minus cos theta into minus 1/2, so this minus get cancelled. Okay, so I just remove this sign. So it could be plus. Again this minus into this minus, but this whole term is positive. Okay, so again this minus, if you multiply, so again this could be minus. So this is plus. Okay, so therefore again in this case this term is negative. Okay, so this could be minus 0.5 cos theta. This is plus 0.5 cos theta. So this term and this term get cancelled. Okay, then what is remaining? This minus and this minus. So it could be root 3 by 2, root 3 by 2. So it could be root 3 if you take sin theta common from this term. कुछ गलत हुआ क्या अपना?
यस सर, माइनस साइन मल्टीप्लाई नहीं किया अंदर ब्रैकेट के।
अच्छा, मतलब ये पॉजिटिव हो जाएगा।
हाँ।
और व्हाट अबाउट दिस? अच्छा,
सर दोनों नेगेटिव ही रहेंगे।
वो तो प्लस आना चाहिए दोनों। फार्मूला सही है ना? cos a प्लस बी इज इक्वल टू cos a cos b माइनस sin a sin b, और cos a cos b प्लस sin a sin b है।
नहीं सर, माइनस है।
माइनस है या प्लस है? प्लीज चेक इट। cos a cos b प्लस sin a, सॉरी cos a प्लस b का फार्मूला क्या है? प्लीज चेक इट। cos a प्लस b because I have not simplified it. I have direct final expression. I am simplifying here. I have written the formula somewhere.
सर
हाँ बोला.
सर ते मायनसची साईन जे आहे ना अंदर मल्टिप्लाय नाही केली ब्रॅकेट मध्ये म्हणून तसं झालं.
अच्छा.
मायनस कॉस थीटा प्लस 240 आहे ना.
हो
तर
हो.
आपण त्याला एक्सपांड केल्यानंतर ती मायनसची साईन एकाच टर्मला मल्टिप्लाय केली, सेकंड टर्मला मल्टिप्लाय नाही केली. तिथे पॉझिटिव्ह येते, मग पॉझिटिव्ह साईन थीटा √3/2.
ओके ओके. हा पॉझिटिव्ह येऊन जाईल आणि सॉरी आपण डबलच लिहूया ते. काय छोट्या जागेमध्ये प्रॉब्लेम होतो तो. So can you simplify it? I will tell you the final expression. You just apply fundamentally same. You just apply cos A plus B formula and cos A plus B formula. You can simplify this. So you will get the expression V S1 S3 is equal to, ये आ जाएगा आपका शायद से ये दोनों प्लस हो जाएंगे साइन थीटा प्लस साइन, इट कुड बी 2 साइन थीटा √3/2 हो जाएगा. ओके, सो 2 गेट कैंसल, तो सिंपली हो जाएगा √3 A टाइम्स VR साइन ओमेगा T into sin theta. Okay, so you just apply those formulae and you will get the expression like this: V S1 S3 is equal to √3 A times VR sin omega T sin theta. So give equation number 5 for this. You just check the formula of sin A plus B, and in this way you can apply the formula and find out V S1 S3. Okay, so note down the final expression V S1 S3. So the line voltage between the terminals S1 and S3 is given by √3 K VR sin omega T sin theta. Okay, where this VR sin omega T is the input, which is constant, that is the RMS value of input voltage applied to the rotor. So therefore line voltage between S1 and S3 is directly proportional to the sine of angle between the rotor, that is theta. Okay, then similarly you can determine the line voltages between remaining terminal. So S1 S3 हो गया. Tell me the expression for V S1 S2. What is the expression for V S1 S2 or V S2 S3? First take V S2 S3. So with respect to S1 S3, similarly you can determine between S2 S3. So S1 S3 किसको proportional है? Sin of theta. Okay, so S2 S3 किस में रहेगा? This S2 and S3. S1 S3 में है theta. तो S2 S3 में क्या रहेगा? Theta plus 120 degree. So therefore you can also, जैसे हमने ये simplify किया, same way you can simplify for S2 S3. So S2 equation you have S2n, so it could be given by V S2n minus of V S3n. Okay, so you just substitute the values of this equation 3 and 4. Okay, simplify it, you will get the formula like this. Okay, so by using this formula we can easily derive it. So write down the expression for V S2 S3, because in the examination we don't have much time to simplify it. Okay, so better way, you just prove any one expression and with respect to that you can derive another one. Okay, so therefore V S2 S3 will be given by K times VR sin of omega T इंटू साइन ऑफ, अभी यहाँ पर ये अगर साइन थीटा है तो नेक्स्ट आएगा आपका साइन थीटा प्लस 120 डिग्री, तो V(S2 S3 विल बी गिवन बाय साइन थीटा प्लस 120 डिग्री. आप प्रूव कर सकते हो मैथमेटिकली भी इसको. ओके, so later on you can prove it. So the equation number 6 for this. Then similarly in between अभी कौन सा बचा है लाइन वोल्टेज, S1 S3 हो गया, S1 S3 हो गया, S2 S3 हो गया, अभी बचा S1 S2. तो V(S1 S2 इक्वल टू K टाइम्स VR साइन ऑफ ओमेगा टी इंटू साइन ऑफ, क्या आएगा नेक्स्ट, थीटा प्लस 240 डिग्री. The equation number 7 for this. अभी ये you see this, why we are getting S1 S3 is proportional to sine of theta, because if you carefully observe this figure 2, you see this, ये जो रोटर एक्सिस है, रोटर एक्सिस कौन से वाइंडिंग के एक्सिस को कोइंसाइड कर रहा है, your rotor winding axis is coincide with S1 winding axis approximately. Okay, so that's why the line voltage S1 S3 is proportional to sine of theta. Then with respect to them, we have determined in the remaining winding. So therefore S1 S3 sine theta, then S2 S3 theta plus 120 degree, and then S1 S2 theta plus 240 degree. Okay, so in this way you can remember this. These are the line voltages of or the terminal voltage of synchro transmitter. Okay, now the most important thing is that what do we mean by electrical zeroing of synchro transmitter? Okay, so many times this question is asked in the theory examination. State and explain synchro as an transducer. Okay, so in that what is expected? We just start with the construction of synchro transmitter, principle of operation, and then voltages, phase voltages and line voltages, and then last one is the electrical zero position. And why this electrical zero position is required? Because whenever we use synchro pair as a error detector, so for that purpose we require what will be the reference position of both the synchro transmitter and synchro receiver. So for that purpose, in order to specify the reference position, for that purpose we are using this electrical zeroing. So what do we mean by electrical zero? Electrical zero of synchro transmitter. Okay, so that we will see with respect to this figure 2. Okay, so now we see that the voltages induced between any two terminal S1 S2 S1 S3 or S3 S1. So these are the expression, and we have seen that these voltages are proportional to the sine of angle between the rotor axis and the stator winding axis. Okay, so what do we mean by electrical zero and how it can be achieved in a synchro transmitter? Okay, so it will clear that from equation number, we just consider the equation number 5. Okay, so when you substitute in equation 5, when you substitute theta is equal to 0, what you will observe? or when we consider when theta is equal to 0 degree. What are the observations from equation 2, 3, 4 and 5, 6, 7? What are your observation? And how will you make theta is equal to 0? Tell me first this thing. Yes. How will you make this theta is equal to 0? For that purpose, what we have to do? What is theta?
Reference
Theta is the theta. You see this. Theta is the angle between rotor axis and the stator winding axis. ओके अभी एग्जांपल के लिए हमने थीटा एंगल कंसीडर किया है स्टेटर S2 वाइंडिंग एक्सिस एंड द रोटर वाइंडिंग एक्सिस, इसमें हमने थीटा कंसीडर किया है. ओके सो नाउ फॉर दिस रोटर पोजीशन दिस एंगल इज थीटा. सो हाउ विल यू मेक दिस एंगल 0? थीटा को अगर 0 करना है तो क्या करना पड़ेगा हमें? वी हैव टू रोटेट दिस रोटर इन क्लॉकवाइज डायरेक्शन बाय एन एंगल थीटा. Okay, so when you rotate this rotor, let's say this is your axis of rotor. Okay, so when you rotate this rotor in clockwise direction by theta, so as you move the rotor position like this, and when this rotor axis is coincide with the S2 winding axis, what is the angle between the S2 winding axis and rotor winding axis? For this position, it is 0. Okay, so that means we say that when we coincide a rotor winding axis with any one winding axis, the angle could be 0. अगर आप ये रोटर वाइंडिंग का एक्सिस S1 वाइंडिंग के एक्सिस के साथ में ये करते हो तो एट दैट टाइम द एंगल बिटवीन S1 वाइंडिंग एंड दिस रोटर वाइंडिंग एक्सिस इज 0. Clear? So therefore in this way, we can make the rotor angle theta could be 0. So for this, what is the reference position we are assuming in figure 2? For this position, we have to rotate this rotor of synchro transmitter in clockwise direction by an angle theta. So at this position, your rotor axis is coincide with S2 winding axis. And okay, and this position of rotor is called as electrical zero of synchro transmitter. Now, why it is called as electrical zero of synchro transmitter? So that we can prove with the help of this equation 2, 3, 4 and 5, 6, 7. You see this here. What do you mean by electrical zeroing? Okay, so everybody got this. How we make theta is equal to 0? What is the meaning of theta is equal to 0? Theta is equal to 0 means you just coincide the stator axis, any one stator winding axis with the rotor axis. Okay, so here in this diagram, if you rotate this rotor by angle theta in clockwise direction, so your rotor winding axis is coincide with this S2 winding axis. Okay, so therefore the angle between S2 winding and rotor winding axis is 0. So that means we say that our theta is 0 in this case. Okay, and when theta is equal to 0, you just substitute this theta is equal to 0 in equation 2, 3, 4, 5, 6, 7. What is your observations from equation 3? What is cos of 0? From equation 3, here cos 0 is 1. Okay, so therefore we say that maximum voltage is inducing S2N. So as Vs2N, the voltage is maximum. Voltage induced in the Vs2N is maximum because the angle theta is 0. Then similarly, In case, and then what about the S1N and S3N? The magnitude of voltage induced in S1N and S3N is smaller than the voltage induced in S2 winding. Why is it so? Because as this rotor winding axis coincides with S2 winding axis, the maximum amount of flux is linking with the S2 winding only, and only small amount of flux is cut by the S1 winding and S3 winding. So therefore, the voltage induced in S1 winding and S3 winding is lesser than the S2 winding. Okay, then the next part, what is its effect on the line voltages or terminal voltages? Okay, by coinciding the rotor winding axis with any one stator winding axis. So tell me the value of S1, S3 for theta is equal to 0. What you will see this? What is the value of S1, S3? When you make theta is equal to 0,
0.
it could be 0. Okay, so therefore S1, S3 is 0. Okay, so that is why this position is called as the electrical zero of synchro transmitter. So what is electrical zero of synchro transmitter? Electrical zero is nothing but simply coincide a rotor winding axis with any one stator winding axis, and when you do this, what will happen? जो वाइंडिंग के साथ में आपने रोटर वाइंडिंग का एक्सिस कोइंसाइड किया है, वो वाइंडिंग में मैक्सिमम वोल्टेज इंड्यूस होगा. व्हाट अबाउट द रेस्ट ऑफ द टू वाइंडिंग्स? अभी रेस्ट ऑफ द टू वाइंडिंग्स क्या है? हमने यहाँ पर S2 के साथ में लिंक किया, तो ये आ गया आपका VS2N, उसमें मैक्सिमम वोल्टेज मिल गया. देन रिमेनिंग टू वाइंडिंग्स कौन से? S1 और S3. So this is your S1 and S3. So if you take a phase difference of voltages, VS1, S3 is nothing but it is the phase difference of VS1N and VS3N. Okay, so the phase difference of the voltages in the remaining two phases is equal to 0. So that's why this is called as the electrical zeroing of synchro transmitter. Are you getting it? What do you mean by electrical zero? Why it is called electrical zero? Because जो वाइंडिंग के साथ में आप रोटर एक्सिस को कोइंसाइड कर रहे हो, वो वाइंडिंग में वोल्टेज मैक्सिमम इंड्यूस होगा. Because and why maximum? Because maximum flux is linking with that stator winding. Okay, और remaining winding में कुछ कम वोल्टेज डेवलप होगा, जितना S2 में डेवलप होगा उतना नहीं होगा. बट व्हाट आर द वोल्टेज इंड्यूस इन रेस्ट ऑफ द वाइंडिंग? इफ यू टेक द फेज डिफरेंस ऑफ द वोल्टेजेस इन द रिमेनिंग वाइंडिंग, so that phase difference could be 0. So that's why this position is referred to as electrical zero of synchro transmitter. And what is the use of this electrical zero? So generally this electrical zero position is used for specifying the reference position in the angular position control system. So where is the application of this synchro transmitter? So generally this synchro transmitter application is that, or synchro transmitter or synchro receiver, pair of synchro. So generally used for the determining the torque in case of servo mechanism. Okay, so for that purpose this is used. So this is all about the electrical zero of synchro transmitter. So this is all about the synchro as an transducer and synchro as how we achieve the electrical zeroing. So you just remember, in case of electrical zeroing, simply remember that simply coincide the rotor winding axis with any one axis of winding. So at that time जो winding के साथ में आपने coincide किया, वो winding में maximum voltage मिलेगा, और rest of the जो भी दो phases रहेंगे उसमें अगर आप voltage difference लेते हो, so their voltage difference could be 0. So that's why it is called electrical zero. Okay, so this is all about synchro as a transducer. Is it clear to everybody? Then we go for next part, that is synchro as a error detector. Okay. Shall I rub this? Okay. The next heading, synchro as a error detector. Let's draw the diagram first with the heading synchro as an transducer. Here is synchro as an error detector. So how will you develop a circuit diagram of synchro as a error detector? In potentiometer as an error detector, we require the two similar pots. One part can be act as a reference and another part can be used for the actual measurement. Okay, so similarly here, synchro as an error detector, which is generally also called as the synchro pair. Synchro pair, and pair of synchro consisting of two units. Okay, so unit 1 is nothing but your synchro transmitter. Synchro transmitter. Okay, so we have already seen the constructional detail of synchro transmitter, its working principle and its electrical zeroing. Then unit 2, it also called as synchro receiver. Synchro receiver, or sometimes it is also called as control transformer. Control transformer. You can use any one notation. So these are the two units present in the pair of synchro. So therefore we have, and the constructionally they are same, only certain changes will be there between the synchro transmitter construction and synchro receiver construction. So that we will see. First of all, we discuss about synchro receiver construction, and then we discuss about the how synchro can be act as a error detector. Okay. So let's take, first we draw a synchro transmitter. Okay. So you see this. This is S2 winding. This is S1 winding. This is S3 winding. So give the name S2, S1, S3. Okay. So here I can represent the synchro transmitter in a electrical zero position. Okay, so why electrical zero? Because this is the axis of your S2 winding and this is the axis of your rotor winding. So both axes are coincide. So that's why your synchro transmitter is under electrical zero position. So whenever we are using it for error detection purpose, we always use the electrical zero positions of synchro transmitter and control transmitter at the time of start. Okay, so therefore, so this is your constructional detail of synchro transmitter for error detection purpose. Okay, then the rotor winding of synchro transmitter is supplied with a single phase supply. So this is your AC supply, input AC supply. Okay, then we have second unit, similar unit. It carries 3 winding. Displaced by 120 degree each apart. So this is S1, sorry, S2, S1, and here is S2. So what we have done, so this is your first pair, This is called synchro transmitter. Synchro transmitter. This is called first unit. Then second unit is called synchro receiver. Synchro receiver, or which is also called as control transformer. Okay. Then what about the rotor construction? Okay. So the rotor of synchro transmitter, sorry, synchro receiver is actually a cylindrical type. But for simplicity, I can show here cylindric salient pole type. But actually, this is not a rotor construction of synchro receiver. Actually, it is a cylindrical type rotor construction. Cylindrical type. But for simplicity, I have shown here a dumbbell type rotor construction. So this is the axis of your rotor of synchro receiver or control transformer. So again, this rotor carries a rotor winding. So these are the slip rings. So this is the output. So across this rotor winding, we are getting a error voltage E. Okay, so give the figure for synchro as a error detector. Synchro as an error detector. So let's say the rotor position of synchro transmitter is say theta, or we can say that theta t. At this position, the theta t is 0. Okay, T stands for transmitter, and the rotor angle of synchro receiver is denoted by theta r. Or theta c. You can use any notation. C stands for control transformer. Okay, so this is a simple diagram of synchro as an error detector. So if you carefully observe that this is called as pair of synchro. So pair of synchro consisting of two units, synchro transmitter and synchro receiver. Then how is the connection? So here we have what we have done. Simply the stator winding terminals S1, S2 and S3 terminal of synchro transmitter is directly connected to the S1, S2 terminals of synchro receiver. Okay. Then the rotor winding of synchro transmitter is supplied with the input AC supply, and here we have measuring the output. We are getting the error voltage across the rotor winding of your synchro receiver. So these are the simple connections of synchro as an error detector. Okay. In this way, you can remember this diagram. So please draw this diagram. Then we discuss about the operation of synchro as an error detector. Okay, so already the time is over. Okay, so in the next lecture we are going to discuss the operation of this synchro as an error detector. So before that, only one part I am going to complete about the how is the construction of synchro receiver. Okay, so what is the basic difference between synchro transmitter and synchro receiver? The constructionally there is no difference between the construction of synchro transmitter and synchro receiver. Only there will be one change. The rotor of synchro transmitter is made up of dumbbell type or salient pole type. Salient pole type. As in case of synchro receiver, the rotor is cylindrical type. Rotor is cylindrical type. So only that will be the change in the construction of synchro transmitter and synchro receiver. Okay. Again, rest of the part is same. Okay. Then what we have seen, we have already discussed how is the connection. The stator terminals of synchro transmitter is directly connected to the stator terminals of synchro receiver. Rotor winding is supplied with the input AC supply, and across the rotor terminals of synchro receiver, we are getting the error voltage. Then we see the working principle. When single phase AC supply is given to the rotor winding of synchro transmitter, it may develop the sinusoidally varying flux which can be distributed along the stator periphery, and according to Faraday's law of electromagnetic induction, the voltages are induced in the S1, S2 and S3 winding. And what is the voltages induced in S1, S2 winding? That voltage is directly apply input to the three stator windings of synchro receiver. Then let's say this is the current direction. Okay, so currents are flowing inside, and here in case of synchro transmitter, currents are flowing out. Okay, so therefore water is against three-phase stator winding develops the rotating magnetic field, and that rotating magnetic field is swap over the rotor winding, and that as the rotor cuts the flux and EMF is induced in the rotor winding. So therefore this is E. So this is a simple operating principle of synchro as an error detector. Okay, so in the next lecture we are going to discuss it. So if you have any doubt, please ask.